Well, hey everyone, and welcome to our physics homework tutorial.
We hope you find this tutorial helpful in your study of physics, and if you do, please visit our website at www.physicsvodcast.com.
There you're going to find over 200 physics examples in every topic of physics. It's sure to help you get through that physics homework. We'll see you then. Well, hello everyone, and welcome back to another problem with Sioux Falls physics teachers. Today we're continuing to look at friction, this time with an adjusted normal force. We have a student pushing a 70 kilogram couch with an applied force of 300 newtons. However, that force is directed down at an angle of 12 degrees with the horizontal. The couch moves with a constant velocity. Calculate the coefficient of friction between the couch and the floor that it is on. Well, first thing we will want, of course, is to draw a free body diagram of this situation. And again, notice they didn't specifically include that as part of the problem, but in a situation like this where you have a lot of different forces to keep track of, it is definitely worth taking a little bit of extra time to make that diagram. First, we'll find the weight of the couch directed straight down. Notice they've given us 70 kilograms, and at this point hopefully you're getting pretty good at just taking that 70 kilograms, multiplying times 9.8, and we get a force of 686 newtons. Now notice that most of the time we would have just real quickly put the normal force on there with an equal amount. However, this time we have this force over here to deal with. Okay, that force is in the angle of 12 degrees, which means it's in both the horizontal and vertical directions. And so that means that we're going to have to take it into account before we actually do the normal force. To do this, let's start by making kind of a separate free body diagram of this part. We have 300 newtons as our resultant. And notice that that's directed down and to the right. So we have really two components of that applied force. One is the component in the y direction, the downwards part. One is the component in the x direction, or the horizontal part. To do this, we've been given the angle of 12 degrees. So now we're back to a little bit of trig here. Doesn't really matter which order we do these in. We'll start with the y component, which is opposite. So the sine of 12 degrees would be opposite over hypotenuse, and that then would be opposite side, f sub y, over the hypotenuse of 300 newtons, and that gives us a vertical component of 62.3 newtons. Next, we can do the horizontal component, and the horizontal component is the adjacent side, and so in this case then we would be using the cosine of 12 degrees, and that's going to be equal to the x component over our hypotenuse, which is again 300 newtons, and that means that our x component is equal to 293 newtons. So now that we have those components, we can add them to our diagram. Again, 62.3 newtons is how much the student is pushing in the downwards direction, and then 293 newtons is how much the student is pushing in the horizontal direction. Now we're ready to do some work as far as finding the normal force.
Okay, so to find the normal force, we have to consider two factors: the weight of the couch and the amount of force that is being pushed in the downward direction as a result of the student. So, our normal force now is going to equal the weight plus our F sub y. So adding the 686 newtons of weight plus the 62.3 newtons of F sub y, we get a new normal force then that is being supplied by the floor upward of 748.3 newtons. Now that we know that normal force, we are ready to calculate our coefficient of friction. Okay? So, frictional force is equal to mu times the normal force. Our frictional force is going to be equal to the force that is being applied in the x direction, the 293 newtons. It does tell us that this couch moves with a constant velocity, so we know that the applied force and the frictional force have to be equal to each other. So our frictional force is equal to 293 newtons. We're trying to find the coefficient of friction then, and the normal force that we calculated a minute ago, 748.3. And solving for mu, we get a coefficient of friction of 0.39.